Hello all. In this video, we will see working of second chance page replacement algorithm with the help of an example. This algorithm is also called as clock page replacement algorithm. So here is the question. Consider a page reference string. We want to know how many page faults would incur for second chance or clock page replacement algorithm with memory of 3 frames. So let me write the page reference string again. 2, 3, 2, 1, 5, 2, 4, 5, 3, 2, 5, 2. Okay. We are given a memory with 3 frames, right? Here also we are going to make use of a FIFO queue. Okay. And the distinct pages which we have are 1, 2, 3, 4 and 5, and we will also maintain their reference bit. Okay, so whenever the page is referred, we will make the reference bit 1 for these pages. Okay, so we want page number 2, it's not there, so there is a page fault, so we bring that page into main memory. Okay, we insert that page onto the queue, and the reference bit of that page is set to 1 as we have referred that page. Then we need page number 3. Again, page number 3 is not there in main memory. So what we do is we bring that page into main memory as we have space. We copy that page into the queue and we make the reference bit of that page to 1. Then we again need page number 2. When we again need page number 2 is already there, right? So we can simply use that page, and since we have used that page again, the reference bit is set to 1. I know the reference bit was already 1, but we still make it 1 just to make sure that we don't forget, right? So page reference bit for 2 is 1 again, so the page is again referred. Then we need page number 1. When we need page number 1, same story, memory is there, so we bring that page into main memory, that page is inserted into the queue. Okay, and the reference bit for that page is made 1. Okay, then we need page number 5. Okay, now the replacement will begin. The algorithm is second chance. Second chance is very similar to FIFO. So what we do is we look at the queue, which page was brought into the main memory first, page number 2. So we remove that page from the queue. We look at its reference bit. Since this page reference bit is 1, we will give this page a second chance. So we will not replace this page as of now because the page is just referred, so we give this page a second chance. Now when we give this page a second chance, what we are going to do is we are going to insert that page back onto the queue and we make the reference bit 0. Okay, since we have given a second chance to this page. Then we look to the next page. We look at page number 3. We remove that page from the queue. We look at its reference bit. Reference bit for page 3 is also 1. So we give this page a second chance and we bring that page into the queue again. Okay. Then we look at page number 1. Page number 1 is removed from the queue, but the reference bit for page 1 is 1. So we give this page a second chance and we insert that page onto the queue again. Okay. And then we look at the queue, so we remove page 2. Page 2's reference bit is 0, so 2 is removed from the queue and 2 is thrown out of memory and 5 is taken in, and then we have 531. Okay, so 5 is taken into the queue and the reference bit for 5 is 1. Okay, then we need page number 2 again. So what we are going to do, we are going to remove a page from queue, which is 3. Reference bit is 0, so we are going to replace that page. So what we do is 5, then 3 is thrown out, 2 is taken in, 1. So 2 is inserted back onto the queue, and since 2 is used now, the reference bit for 2 again becomes 1. Okay, because we have used that page. Then we need page 4, so we remove 1 reference bit for 1 is 0, so we replace that page. So 5 and 2 are as it is. Instead of 1 we get 4, so 4 is taken into the queue. Reference bit for 4 is 1 because we have used it. Then we need 5 is already there, so we simply use that page. Reference bit becomes 1. Then we need 3 is not there, so we look at the queue. We remove 5, but the reference bit for 5 is 1, so 5 gets a second chance. When a page gets a second chance, the page is inserted back onto the queue and the reference bit is cleared to 0. Then we take out 2, same story, the reference bit is 1, so we give that page a second chance, the reference bit is cleared to 0. We take the next page, which is 4, the reference bit is 1, so we give that page a second chance. Since that page gets a second chance, we insert that page onto the queue and the reference bit is cleared to 0. And then we remove 5, 5's reference bit is 0, so we remove 5 and we take 3 inside. We will get 3, 2 and 4. Okay, so since we take 3 is inserted into the queue, 3 is used, so reference bit is 1. Now we need page 2. Page 2 is already there, so we use it, so reference bit is 1. Okay, then we need 5. Since now we need 5, what we do is we look at the queue, we remove 2, but 2's reference bit is 1, so page 2 gets a second chance. Since this page gets a second chance, the page is inserted back onto the queue and the reference bit is cleared to 0. Then we remove 4 and reference bit for 4 is 0, so what we do is we replace this page 4, right? So 4 is moved out, so we have 3, 2 and then 5. Since 5 is taken into main memory, 5 is inserted into the queue and the reference bit is 1. And now we need page 2. Page 2 is already there, so we use it, reference bit is 1. So how many page faults you got? 1, 2, 3, 4, 5, 6, 7, 8. So the number of page faults with second chance is equal to 1, 2, 3, 4, 5, 6, 7, 8 page faults you get. Okay, I hope you have understood this. Thank you.